This lecture is all about earthquakes, so you should be in the earthquakes section of the earthquakes folder of week 2. So when we're talking about earthquakes, we'll have 3 lectures. The first is going to be about what earthquakes are, how they occur over and over, and what faults are and different types of faults that we have. The second one will be about magnitude and intensity of earthquakes, and then the third one will be the effects of earthquakes. So again, if you have the book, this is chapter 5. All right, before you do that, again, I realize you got a lot of lectures that you're watching here, so a good thing to kind of review or recap would be the 3 types of plate boundaries: convergent, divergent, transform. And what direction of movement does each type have? So when you're taking this, I'm starting you off with a quiz question. So you'll have the quiz open as you're going through this lecture. So the first 2 questions are going to be using these 2 maps here. So the first question is using this map on the top left and the map on the bottom right. Which of the following cities, you got to check the boxes for which ones would be likely to experience an earthquake relative due to their location relative to a plate boundary. So you need to match up these 2 maps to see where plate boundaries overlap with cities for your first question. And then based on that, to review the content from plate tectonics, the second question is using these maps, what groups of cities experiences subduction zone earthquakes. So you'll have to remember what a subduction zone is, figure out what kind of plate boundary that is, and then use the map to figure out which cities correspond to those types of plate boundaries. So let's talk about how many earthquakes occur every year. At the lab that you'll be doing with the earthquakes section of this course, we'll have you go to a website and you're going to be analyzing how many earthquakes happen in a given day. But if we're looking at the number of earthquakes that happen every year, there's more than 1 million earthquakes that happen every single year. Most of them are small. They're going to be considered minor, so there might be like 1.3 million of those. That's an estimated number each year. And then as you go up magnitude, so as they get stronger and stronger, we usually only have one really, really big earthquake every year on average, and about 17 major earthquakes every year. So you'll access this when you complete the lab for this week. You'll be doing some earthquake analysis using this website here. It's basically a real time updated website that lets you look at current and actively occurring earthquakes, which is pretty cool. So if an earthquake happens, basically within a minute or so, it gets uploaded to a website and we can tell right away when the latest earthquakes have happened on Earth. All right, so just to get into earthquakes, just to define what an earthquake is a movement of the lithosphere. Again, just to remind you, the lithosphere is the crust, all of the crust plus the upper mantle, and tectonic plates are the lithosphere or the lithospheric plates. So when we're talking about an earthquake, what's happening is that the outermost rigid layer of Earth is moving very rapidly. That creates shaking, as we know. That creates things like tsunami and something called liquefaction, which we'll talk about as well. So an earthquake is just a rapid movement of the lithosphere, usually in response to tectonic plates moving. Earthquakes occur on faults. They don't always occur where a fault is already there. Like the San Andreas Fault, for example, earthquakes happen on the San Andreas Fault over and over. You don't already have to have an established fault to have an earthquake. You can form new faults when an earthquake happens as well. So a fault basically is just a crack in rock or a fracture where 2 blocks of rock move past each other. They could either be moving away from each other, towards each other, or sliding past each other. So in this image here, basically we have a person for scale, and then the crack that goes kind of horizontally through this picture, that shows you a fault. So anytime an earthquake happens, basically this left side of the fault drops down relative to the right side. And the reason I know that is because these gray layers here, they should line up in terms of how geologic formations naturally form. You have nice flat layers of rock. So the fact that these layers are offset from each other, it's because earthquakes have caused these rocks to kind of move and offset. On the right side, this picture is from Alaska. It is a running track here, basically where an earthquake happened, and the right side of this image dropped down to the left side, relative to the left side of the image. 2 more definitions here for you. So we have focus. A focus is underground, where the earthquake movement actually begins. So most earthquakes aren't generated at the surface. They are generated down somewhere beneath Earth's surface at what we call the focus. The focus is where the earthquake starts, and it will move a fault in response to shaking or seismic waves. So focus, if you draw a line straight up from the focus in this diagram here, that's where you'll find the epicenter. So the epicenter is a location on Earth's surface that's directly above the focus. All right, so we usually use the term epicenter when you're talking about the epicenter of the earthquake was in San Francisco or San Jose, but we also use the term focus, and that just tells you where it was underground, where the earthquake actually started. All right, so you should be at quiz question number 3, so you can use this diagram here and basically figure out the kind of word problem that you have for quiz question 3. And again, as always, feel free to pause and then return once you've answered that quiz question. All right, so the next thing we need to talk about is just where earthquakes happen. So earthquakes occur at plate boundaries. So if you have convergent, divergent, and transform plate boundaries, you get earthquakes that will occur there. And depending on the type of plate boundary you can have a more shallow earthquake, or you can have deeper earthquakes at other types of plate boundaries. So in general, if you have a divergent boundary, like the Mid-Atlantic Ridge or the Mid-Ocean Ridge here, or if you have a transform boundary like the San Andreas Fault in California, earthquakes tend to be generated from a more shallow depth, which doesn't always translate to a less severe earthquake, but often it does. So we tend to have less severe earthquakes when you have divergent and transform boundaries. It's more when you have convergent, where one plate is sliding under the other one. That's where you get the really big earthquakes on Earth. But again, if we kind of trace the outline of earthquakes, we could trace the outline of tectonic plates. It corresponds exactly to where earthquakes happen. Just to show you, we got our recap of our plate boundaries here. So we have a transform boundary, 2 plates just sliding past each other like the San Andreas Fault. We get earthquakes, that's your red dots here. If we have 2 plates splitting apart or diverging, like the East African Rift that you learned about, diverging, all the red dots indicate that there's earthquakes that happen there. And same thing, if we have convergent boundaries, 2 plates are colliding, like forming the Himalayas, you get earthquakes. The red dots here indicate that you get earthquakes at that too. So the point of this slide is to show you that all 3 types of plate boundaries, you get earthquakes that will occur. All right, just to show you, if you have 2 plates that are colliding and one goes underneath of the other, you can get earthquakes that are generated at any number of depths. So you can have shallow earthquakes, you can have intermediate earthquakes, and then you can have deep earthquakes as well. A deep earthquake usually means that the earthquake is generated about 400 to 600 kilometers beneath the surface. So if we're looking at faults, we've already defined what a fault is. We can see evidence of faults through aerial imagery, or if you ever go to San Francisco, you can see lots of evidence of fault movement. So I'll start with the easiest one here. So we have this road. This road was paved straight in a straight line. And what has happened is that an earthquake happened. And when that earthquake happened, it broke the ground and offset that road. So the foreground here has moved to the left, and the background here is moved to the right side of this image. So that's a strike slip fault, which we'll talk about in a minute, but the San Andreas Fault, this is what it does to the land surface. Same thing here. If you build a fence, you're trying to keep something in or keep something out. So you don't deliberately build a fence with a gap in it, like this picture on the right side. So when this fence was built, it was all straight together, but there is a fault that passes right through this picture, which is why the fence in the right side is moved to the right relative to the left side. So that's an evidence of a fault. The one on the bottom is more subtle, but this is San Francisco, and there's another road basically that was built straight. If you follow the sidewalk here, what you'll see is that it shoots off to the right and then kind of readjusts itself. What that means is that there was an earthquake and a fault moves right through this image. Earthquake happened and it shifted that sidewalk. Those are subtle ones. Here's an example of a much more extreme effect of an earthquake. So this one is from Alaska, but basically there was a strong enough earthquake that it bent these railroad tracks. So there is a fault that goes right across the diagram here. And one side of the fault moved in one direction, another side of the fault moved in the other direction. So that's why you get these bending of these railroad tracks. All right, so we just have a little bit of terminology to kind of move forward here for a couple minutes. So if we look at faults, not all faults are created equal. Not all cracks in the ground are created equal. There's 3 different types of plate boundaries, and there's 3 different types of faults. So what I want to point out is that most of these diagrams, you should assume that all of these layers should normally just be flat, almost like a layer cake, if that's a good visual for you. They should be flat. And what you're looking for is you're trying to see if those layers on one side has either dropped down or been pushed up relative to the other side. So there's some confusing terminology here, but basically you're trying to look for the block of rock above the fault. So you can imagine, let's say that here's your fault right here. And if your feet were standing on this fault, you're trying to see what would be above your head. So in this case, it's the block on the left. And if that moves down relative to the other side, that's something that we call a normal fault. So let me show you an animation of what that looks like. Normally these layers should be lined up straight across, but an earthquake happens, one side of this fault drops down. And again, if your feet were on this crack right here, what is above your head, if that moves down, that's what we call a normal fault. Here's a picture of what that looks like. So it's not as obvious, I guess, if you're looking at it on a smaller scale, but basically these orange layers, they should line up straight across this diagram. And if you were standing with your feet right here on the fault, what's above your head, it's on the right side. So this orange layer has dropped down relative to the left side. So this is what we call a normal fault. Here's another example. Foreground has dropped down relative to the background, and we have these people here for scale. So if we switch it over and we talk about another type of fault, these are called reverse faults. So a reverse fault is basically the block above the fault moves up in a vertical direction. And typically what you'll get is kind of this overhang that will form on the surface from a reverse fault. So again, if you picture your feet standing on the crack or the fault itself, what is above your head, if that moves up, that's what we call a reverse fault. Here's another diagram or animation of it. Earthquake happens at the focus, and that basically creates this vertical upward movement that we call a reverse fault. For a picture, again, here's your fault. It's this crack that goes straight through the rock layers here. So if you look at this crack right here, you imagine your feet being on this. What you'll notice is that these kind of eroded layers, this side on the left has gotten pushed up relative to the side on the right. So this is another example of real life example of a reverse fault in the field. All right, so your quiz question that you have now, you have an image on the left, you have an image on the right. One of these is a normal fault, one of these is a reverse fault. So your task is to use the diagrams, use the animations, and figure out what type of fault each of these images is. Lastly, the third type of fault is a strike-slip fault. These are the ones that occur at transform boundaries. So one side of the fault is displaced horizontally relative to the other side. So for example, one tectonic plate is going in one direction, one tectonic plate is going in the other direction. And the fault that forms is what we call a strike-slip fault. So again, we see this with kind of offset of roads. We can see it in offset of railroad tracks being bent as well. All right, so to finish up, the last kind of definitions that I want to go through is just some definitions for fault movement. We can also use this term recurrence interval for when we're talking about volcanoes and flooding, which will be the next couple of units. So a recurrence interval tells you how often something happens in a given location. So for example, let's say you have a recurrence interval of 100 years for an earthquake. That means that you expect an earthquake to happen on average every 100 years. It wouldn't be 100 years exactly. It could be 50, it could be 200, but on average, you have an earthquake every 100 years. So that's what we call the recurrence interval. Basically, every large fault or tectonic boundary system that we have estimates of how often earthquakes occur on those faults, and that's built into kind of risk models and things like that. Anyway, so for example, For San Andreas Fault in California, on average, its recurrence interval is 150 years, so they expect a very large earthquake to happen in San Francisco or on the San Andreas Fault every 150 years. So, how does this happen? How do you get an earthquake that occurs over and over and over again in the same location? The way earthquakes work is that you have, over time, on our x-axis here, you have stress or strain on the y-axis. So this is kind of time zero. What happens is that as tectonic plates are moving, they're kind of building up strain or they're building up stress and pressure over time. Rocks can't handle that much stress and handle that much pressure. So what will happen is that once it's under enough stress, it's going to have an earthquake that relieves stress. It relieves the strain or the pressure on that fault. Earthquake happens, resets it, and then it will start over. It will start building up stress, building up pressure, until it has another earthquake that resets the stress, resets the pressure, then it starts again. It starts to go back up in pressure. So a good analogy for this is that if you take a wooden pencil, and you start to bend it, you're adding stress to it until it breaks. The breakage there would be like the earthquake. So the act of actually breaking the pencil would be like the earthquake. You've taken the stress off, and then you could take that pencil again, your smaller chunks of pencil, break them again, have another earthquake. So hopefully that's a good analogy in terms of trying to show you why earthquakes happen over and over on the same location. All right, let's see if this plays. So this has a word in it that you don't need to know, but basically what this is going to show you, this animation here is going to show you how earthquakes happen, how you have relative motion. Basically what an earthquake is when you get stress that's building between two tectonic plates. If they're sliding past each other, moving away from each other, or converging, you'll build up stress, you'll build up pressure. You will get the main shock of the earthquake. It will move the ground. And then you might get aftershocks that will happen as well. All right, so I will end this with a bad geology joke. So tectonic relationships, these two tectonic plates say there's too much friction between us, and then the other tectonic plate says it's not my fault. All right, so you should have a quiz question to finish up here, to finish up this lecture, and then you'll have another one after this one.